we're going to design a test question about the pKa's of an amino acid, a protein. In this case, a tripeptide. So I haven't designed the question yet. Here is a protein. It's a small protein, 3 amino acids together. In our lecture notes, you saw how this was made. It's alanine, aspartic acid, and arginine, which I never fixed on the last one. It's not arg, it's lice. Yeah, I got to go back and fix those notes too. There we go. Oh, sure. Exam amino acid design. Okay. Now the question is, I want the diprotonated form for my exam question because I don't want to start at an extreme where I have fully protonated or fully deprotonated. It kind of gives away too much. So I want you to tell me what this thing's going to look like at the start of the question, keeping in mind, right now it has 4 protons with 4 pKa. The diprotonated will be missing the 2 most acidic hydrogens. That's how acid-base works, people. You take the most acidic protons off before the less acidic one. So you really got to know the lower pKa gets taken off first. And 2.2 is our lowest number. It means this thing doesn't exist like this when it's a diprotonated. It's an O with a what charge? Negative charge. I'm looking for my charge. There they are. A negative charge. And that's one of them. What's the next lowest number? The 3.9 is now going to be a CO2 minus as well. And it's now you've got the diprotonated form. I will be reacting that with one of our traditional acids or bases. We don't know which. This thing's got 2 protons to react still, and it's now got 2 bases to react. So where you took the protons off are now bases. So you got to watch carefully the pair I give you in this question. And it will always be the smaller molecule pairs there. You're going to have to draw the tripeptide in its new form. So I'm going to pick one we're supposed to know, NaHCO3. And that's in equilibrium with, if I do my equilibrium like this, it'll be easier for you to circle arrows. And yeah, that way my equilibrium arrows are separated. And then you got plus sign, lice becomes plus. And I'm going to have the NaHCO3 be the one that's giving up a proton. And we'll go Na2CO3. It's saying the Na is where are they coming from? I don't. Where'd the second Na come? Some of you are bothered by that. Do I care about NAs? No. What is their job? Spectators. I'm going to be crossing them off when I start this question anyway. So the next part of this question will be a box. And you say that box isn't big enough, and I will agree temporarily. And we got that. And what else do we need? We need the question. Well, the question is the same format as our second activity of the day, right here. And maybe the best way is to just snip it. We'll probably get some loose ends. Hello, hello. Yeah, it's got some extra. I don't need the comment there. And here we go. Wait, no, I'm on Word. I'm on ChemDraw. Wow. Okay. Get rid of extraneous. What happened there? Oh, I'm on the wrong software again. I can't be doing any erasing here. Okay, connect the conjugate pairs and fill in. I think everything we need is here. Yeah. So I think we're ready to start. Snipping my snips. If I'm careful, I can make this an activity. Doesn't have activity written on it, but you guys don't care, right? 2, 4, 6, 8, 10, 12. I'm doing this all on the video. I know that right now. Okay. So we're over here. New page. That's funny. You're a very funny man. I mean, what the heck is that? Tell me. Try it again. You think it'll do the same thing again? Yep. I'm seeing it. Snippy. Snippy lost his mind. We have everything we need, right? Right over that symbol. All right, we're going to see stop share. And was there a way to pause the video? All right, ladies and gentlemen, we're back. Everybody's got a copy of this now. We need oh, I think it's that one. That one. Okay. So first of all, you got to look for the pair that is there, but don't do that until you do this. That's a 2- ion, right? Put the minus where it belongs with the oxygen. Thank you. Put the minus where it belongs with the oxygen. Which one of those two is the acid in this pair? The one on the left that has the extra proton. It's always the one with the extra proton. pKa for that acid is 11. You have to learn it. It's called bicarbonate. And please tell me how I can figure out pKb for its conjugate partner. 14 minus 11. Don't get those backwards. I heard somebody get it backwards. Yeah. pKa plus pKb equals 14. That's where you're basing your math on. So if that's an acid, that means this molecule is a base, and it's the conjugate base of this acid. pKb is 14 minus one of those numbers up there. Okay. I have questions for you. Yeah, acids react with bases. So this is a base. The question now is, which of the two sites that lost a proton will get a proton back first? I'll give you a reworked version of that question. Will a pKb of 10.1 react ahead of or behind a pKb, what did I say, 10.1 versus 3.5? Oh, I'm using the wrong number. What's 14? 10.1 and 11.8? Which one's a stronger base? 10.1 for the pKb right here, or 11.8? 10.1, the lower numbers, the more reactive one. So I'll just, here's a reminder of what I just said. Your two choices are pKb, 14 minus 3.9 equals 10.1, or pKb equals 14 minus 2.2 equals 11.8. And it's more than one difference. It's more than 10 times more reactive. Don't pick the wrong one, is what I'm trying to say. You've got to pick this one. It reacts first. If you pick the other one, you're just saying, I don't know anything about acid-base chemistry. I'm having less reactive bases react before more reactive bases. And I get very sad. When did you choose these two? Well, the other ones are acids. There's no place to put a proton. First, I had to establish that this molecule was a base. How did I do that? I established the nature of the thing it's reacting with as an acid. So now the question is, of the base places, which one's the better one? What does a base place mean? Well, the part that doesn't have its proton. This is fully protonated. If you put an H there, you're going to get an octet violation. You're living in a universe that doesn't exist. Same thing down here. You can't put an H on there. You can put an H on a carboxylate, but don't put it on an 11.8 before you put it on a 10.1, because this thing's more than 10 times more reactive. This is a log scale, powers of 10. The difference is more than 1 between this number and this number, therefore it's much more reactive. So 14 minus 3.9 is 10.1. That's the one I'm going to use. That's an answer. This one I'm basically ignoring because it's not relevant. I had to do the math to figure out to cross it off, okay? Now on the test, you can avoid drawing the whole molecule if you're careful. And this is the first time you've done it, so a lot of you are going to make a mistake. But if you carefully circle any piece of the molecule and label it as R, then you only need to draw R for that portion. So I'm going to go all the way up to, oh wow. This ChemDraw did this to me. I'm pleading the fifth here. This ChemDraw added this CH2 when I edited the charge. It was wrong and it's bothering me. Okay. If you notice on my Word, it shouldn't have been, and it did there too. It did there too. Not my Word, my ChemDraw. And then my minus was way off. There you go. It's not bad. Okay. Just fixing stuff. That was CO2 minus attached to CH2. So I'm going to circle everything up to the CH2 in purple. Very clearly. Everything in this circle I'm calling R, and that circle clearly includes the CH2. I hope you see that. So now it goes R is attached to C double bond O with an O, and I need the conjugate acid. What else do I put here? Don't leave it like this. You get 1.5 out of 2. No, you don't even get that. You don't have a proton on there. You might get 0. You got to put a proton in there. Where's it go? On the O to the left. There you go. pKa is 3.9. How did I know that? Well, when it has the proton, we were told it has a pKa of 3.9. That's what this means. So a lot of you are saying, well, there's no proton there. How can there be a pKa? The pKa's are listed if there's a proton there, what's its value? The reason there is no proton there is this thing has lost 2 of its protons. It had 4 pKa's and 2 of them are not showing because it's only the diprotonated form. The one we had in our exercise here was the, we had a different exercise somewhere. Yeah, we had the fully protonated in some exercise. Maybe it was here. No, this is a nightmare. There. Fully protonated form. It was at pH 2.2. Hey, when we got the pH up to 5, it was in its diprotonated form, so it's not even hard to make the diprotonated form, right? Just get the pH up to 5. Then start the question. What question? This question. Okay. So you got a little work to do before you start doing these. Do all the other ones. This is like the top level. Okay. And we're done with that. I think that was